Hi everyone, here I have another power supply, this time much better, 90% efficiency, 230 volts only. A guy told me that it doesn't turn on. Let's see what's inside. Okay, I took it out, 650, very nice power supply, efficient, new, but unfortunately the seal is broken, so somebody did open it. Now I'm gonna use my oscillating transformer for safety and test what we got on the output. Okay, I connected my oscillating transformer, connect the tester, turn the transformer on and turn the switch on, and nothing, not even a flash. So it means the power supply is dead. Now it's time to open it. Okay, I did open it. Fuse is not good. By the way, the power supply was really clean. It's quite rare to see such clean power supply, so it means that it wasn't been working for a long time. So we can check the fuse by taking one lead here and one lead to any AC pins in the middle of that bridge. So we see nothing, so probably the fuse is bad, or maybe there is some broken path from the fuse to the diode bridge. Now let's test the diode bridge. One diode is good, the other is good. So we just keeps on moving lower. Now this black lead in the AC pin and this one on the minus pin. And the third is good, and the fourth is good. Probably again that would be an easy fix, but this time I want to put out the board and see what's back, because this one was proper fix. Let's remove the fuse. Yeah, it's really convenient to use this big soldering iron like this and like this. So the fuse is 6.3 amps, 250 volts. Let's find a proper one, replace it, but before replacing we need to check the rest of the board. So here we have the PFC coil, and after that, through this diode we have 400 volts on this cap. So probably this is a diode 2 transistors are for PFC sector and 2 maybe to switch forward topology, because we have 1 capacitor, not 2. When we have 2 capacitors, it's half bridge. When it's 1, probably it's 2 transistor forward topology. And for standby power supply, we just have 1 PWM controller with built-in MOSFET, which drives this transformer, and we have 5 volts on the green wire here. Okay, let's test the switches. We turn on the diode mode and test randomly. We've already checked that the diode bridge is good. So, oh, it's shorted. Unfortunately, there is a short. Yeah. Yes, so at least 2 transistors are bad. This one probably good. This one probably good, so I thought maybe we would have something easy, but these transistors are bad this time. At least one of them. So one of them died, but the diode bridge was able to get away from this spike, but before the fuse blow. So the diode bridge survived. Okay, it would be more difficult. In the process, I also checked this diode and this diode, and they turned out to be shorted. So I lifted up one leg and you can see that this is shorted and this one is shorted, and the transistor still also shorted. It's pretty severely bad. Okay, I removed one transistor. As you can see, it's completely shorted, but the second one seems fine. So we can see the built-in diode. So this one is good. Okay, so far we've got fuse, 2 diodes, 1 transistor. Let's try to find a replacement and move on. Okay, I found similar parts, put them from this side. It's much easier to test before you move further, maybe because this IC can be bad. And so here I put a little wire in the place of fuse. Now it's turned on. On the cap we see 320. It's falling because I recently turned it on. Here I have my tester and all the voltages are present, and on the cap now we have 380. Perfect. The PFC is working, so now I'm gonna put it back properly, replace the fuse and test it one more time. So I replaced the fuse, put some shrinking tube on it, not really necessary, but just to be like the same, the original one. Replaced this diode, replaced these transistors. Only one was bad, but you should always replace and put similar types of transistors. So it's now, and also I replace this diode PFC. So now I'm gonna put the enclosure back and test it under the load. Okay, as set for checking the output, I have this mass, two big resistors for 100 watts each. Here is my tester connected. Here is my power meter from utility company, just a cheap one, and used one. Now I connected this power supply to the mains, this through this power meter, and now we can put the power now. It's 0 watt. Turn it on. Now we have 16 watts using my tester, the ventilator. I'm gonna load 12 volt rail, and let's see. Now I'm gonna connect. Here you can see the voltage, and it slightly drops, 72 watts. Okay, let's try to make it a little bit more, and 120. So it's actually what I can load it with this 100 watts resistors. But anyway, I think the power supply is fully working and can be used one more time. We saved it. So thanks for watching, stay tuned, and next time I think there wouldn't be not a power supply, but something else. I have other devices to save. Okay, see you next time.